Okay, so homework number 3. You're buying a new car for 24 grand, and the value decreases by 12.5% each year. So first we have to write an exponential decay model for the car. All right, well, this is kind of like those population growth or the tuition growth problem that we had in the chapter 1 notes, or sorry, chapter 7 notes. And so in this one, the idea is, well, let's use V for value of the car, and it's going to be based on time. And the pattern that we've had is we've put an initial value, and then we multiplied that by either a growth factor or a decay factor. And in this case, it's decreasing, so it's going to be a decay factor here to the t. Those are the patterns that we've had so far in our problems about growth or decay. So the initial value we already know is $24,000. So that's V of t. That's V, the initial V. And then the decay factor we have to figure out. Well, you don't want 12.5% of 24,000. That's not what the car is worth. What you really want, you need to think of it as you want 100% minus 12.5%. So what you really want is 87.5% of the car's value. So that's how you're going to figure out what the car is worth each year. So this right here is going to be the decay factor. So that right here is going to go 0.875 if we convert it to a decimal. I want 87.5% of 24,000 because that's what's left for the car's worth each year, 87.5%. So after 3 years, so this is the model. This is the first part of A. And then the second part of A says use the model to estimate the value after 3 years. So I'm going to plug in a 3. So it's going to be 24,000 times 0.875 to the third. And I'll use the calculator here for it. Of course, it won't turn on, so I'll restart it. Maybe. Let's try restarting it one more time. There we go. So 24,000 times 0.875 to the third. $16,078 and let's say 13 cents since we're going to round up there. Okay, part B says, how long will it take for the car to end up with a value of only $8,000? Well, that means we want the V to be 8,000. So 8,000 is going to equal 24,000 times 0.875 to the t. So we're solving for t. So let's isolate the t term. So we're going to get 8,000 divided by 24,000 equals 0.875 to the t, like that. Well, that 8,000 over 24,000 is just 1/3. It's 0.875 to the t. And then at this point, you got to isolate the t somehow. So remember, the hint here is you're going to have to use log base. And anytime you're solving for the exponent, you should remember this rule. If you have b to the c equals a, then that can turn into log base b of a equals c. That's the key right here, this thing. Okay, you turn exponential form into log form. So let's take a look at what our base is. The base is 0.875. The c is the t, and the a is 1/3. So then when I rearrange this thing, I'm going to write log base 0.875 of a, which is 1/3, equals c, which is my t. And then this I can plug into a calculator. So if we go to alpha f2 and then find log base, it's 0.875 and it's 1/3, and that comes out to be t is about 8.23 years. So it'll take 8 years and a few months, and the car will decrease to only $8,000. Okay, hope that helps a little bit.